Well, hello. My name is Scott Grizzard. This is Quiz Review 5B, the 5 p.m. session. I'm from the University of South Florida. This is calculus. I'm supposed to say all those things. Okay, so let's. So these are just the quick problems, right? So, derivative of cosine, negative sine of x. The derivative of this is exp of x. And the derivative of this is 1 over x. Now, this one right here is a limit problem. Please read your problem. The tests are semi-cumulative. We say, oh, it's test is cumulative or test is not cumulative. Well, math is cumulative. Even if we say the tests aren't cumulative, they're cumulative. So you're going to need to keep this fact in mind. So we're not done with these. We're certainly not done with limits, unfortunately, because I think they're disgusting too. They're kind of neat in a very, as a logical exercise, they're kind of neat. But as a computational thing, they're kind of a pain. That one's infinity, right? Because here's 1 over x, and there's that. This is a good thing to just keep in mind. So the limits as you go into infinity or to these asymptotes, these are actually kind of good to hold on to because they have physical meaning. The limits as you go to a point on a continuous function, yeah. Let's get into calculus. They're useful to prove things, but they're just annoying. All right. They're evil, wait, I need to ask 1 to 5 how we feel about that. So 1 to 5, how do we feel about that? Now that I've just said that I find limits somewhat annoying, at least finite ones. The ones that are infinite are kind of cool. Let's see. Question 1. 1, 2, 3, 4, 5. So just make sure you're reading carefully. The biggest mistake here is people are trying to take the derivative instead of just reading carefully. Read what the problem's asking. All right, so we feel okay about that. So now what we're going to do is take the derivative of 2 plus 5x squared. Now, the first way is the absolute minimal. So this is the minimal way to do it in purple here. The minimal thing I need to say is I need to say 0 plus 10x. If it's a polynomial, no one's going to criticize you for not having intermediate steps. The only thing that's important, really important here, is for communication-wise, is you must have that 0. So simply writing 10x ain't going to do it. Now, you can do a little bit more detail if you want. Okay? So let's say we want a little bit more detail on this. So we go, okay, well, this equals, I'll do sum rule, d over dx of 2 plus d over dx of 5x squared, and then I'll do constant rule and constant multiple rule, and I'll get a 0 plus a 5 d over dx of x squared, which equals, now I do a power rule, and I get 0. I don't get 0. 0 can go away now. 5 times 2x to the first, which equals, or x to the 2 minus 1 if you insist, 10x. Okay. How do we feel about that one, 1 to 5? Both how to do it and then what you kind of need to write. If it's simple, you could skip the steps that you do the sum rule and the constant. It's a polynomial, but you do need to show what happened to the 0. So how do we feel about that? Both things, like how to do it excuse me, and then how to communicate it. So you just need the stuff in purple. But as I said, you can do the other stuff. But the important thing is just show what happens to the zero. That's important. Somehow you have to, you could write, this is a constant goes, if you do this, you could sketch in here, this goes to zero in here and then skip it. You just have to say where it went. You can write right above the thing, this goes to zero, and then just write the 10x. But you just have to say what happened to the thing. You could communicate that a number of ways. Okay. That was question 2A. I didn't change the poll thing. All right, this one's a little bit different. I am going to sum this out, but I'm going to do the algebra first. I don't really have to sum it out. It's just power rule. But I am going to do this bit of algebra first, and I'm going to make this a step. So I haven't evaluated any derivatives yet. I'll sum out the other one. I might just write algebra here just to remind myself. Note that I still have, oops, and that should be d over dy, not x. Notice I still have this take the derivative of thing. Right, because y to the 1/2 plus y to the negative 2 does not equal 1/2 y to the negative 1/2. Right? You have to use the power rule, but you haven't evaluated the derivative yet. And that's very important, because if you write power sum stuff, if you write two things that are not equal between an equal sign, people are going to go. There will be, death, destruction, mayhem, low quiz grades, low test grades. One plus y to the negative 2 minus 1. Oops, I need the negative 2 to come out first. Negative 2y to the negative 2 minus 1. Now, let's put a minus there. Minus 2 to the negative 3. Minus 2 to the negative 3. Yeah, right. 2y to the negative 3. Now, do you have to do this step? No. You don't need this step to communicate, but I always, if I'm dealing with a fraction, okay, if I'm dealing with 1/2, I do it enough that I'll write negative 1/2. But if I'm dealing with anything negative or anything that's a fraction other than 1/2, I like to write them out. That's a personal preference. That's like a personal choice on my account. You don't have to do it. But I mess that up. I'm a professional, and I mess that up all the time. I mess up a lot of things when I'm on the board, but I really mess up. Even when I'm not looking at it, I'll mess this up if I don't do it that way. So, you could, if you're confident in your ability to do math, and your ability to not go the wrong direction without writing the -1, go for it. But if you're like me, sometimes you go the wrong direction. You just need a little reminder. Do it. Also, if you mess this up, but you did it here, it shows you knew what the rule was, and then your mistake is a piece of algebra, which is like half a point, as opposed to messing up the rule, which is, the 2 points, the whole kit and caboodle. So just things to think about. All right, so how do we feel there about question 2B? Or not to be? Okay. Moving on here to C. So dv du equals the derivative with respect to u. Notice there's no v here. I'm doing a verb. Pi sine u minus 2 to the u. I am going to break this one up. This one's got some stuff going on here. I'm going to go, oops, that's an R. I'm going to go ahead and do that. So I'm going to get pi times d over du sine of u. This is a constant, so it just stays. Minus d over du 2 to the u. Now, when it comes to exponential functions, especially e to the x, because it's its own derivative, it's very easy to lose track if you've done it. All right? The 2's, okay, you're going to generate a constant ln of 2, so it's not so bad. But when it comes to e to the x, every time I do e to the x or exp of x, I make sure that I'm writing this down. Have I taken the derivative yet or not? Because it's very easy to forget. Have you taken it or not? Especially when you start dealing with products and chains and mixing them. All right, so this is going to be pi times the derivative of this is cosine minus, and then the derivative of this with the exponential rule is ln of 2 times 2 to the u. This is not a power rule question. This is an exponential question. All right? How do we feel about that? Right, it's a different question. It is very easy to do those by accident as power rules, but they're not. They're exponential rules because now the variable is moving with the exponent. Whereas opposed to the power rule, the variable is the exponent's constant and the base is moving with x or with u. That's hard, by the way. Getting those set. What do I mean, by the way, by moving? I've mentioned this before when I did limits. And the reason I did that when I mentioned limits was for this reason. What do I mean by moving? Right? What's the thing that moves? It's the thing I'm taking the derivative in terms of. Or anything that is driven by the thing I'm taking the derivative in terms of. So I've got, you know, if I give a little bit of nudge to u, this 2 to the u, the exponent gets the little nudge. And if you don't know what I'm talking about, I linked a bunch of 3 blue, 1 brown, or 3 brown, 1 blue, or whichever videos in the canvas about that. And I would watch the ones, especially where he talks about the little bit of nudges, because it's a very intuitive notion. Instead of that limit business, it's a very intuitive notion about what the derivative is doing, and it helps you think through some of these things. All right. Finish the statement of the product rule. D over dx of f of x times g of x plus f of x times d over dx of g of x. Okay, another way to write it, you can do this up here, is f prime of x times g of x plus f of x times g prime of x. The reason I prefer this notation, well, one, because you can, when you chain rules together, like we're going to start doing, it's easier to just work with. The prime notation is kind of a pain. But the other reason is it's easy to lose these things. I also like the straight Leibniz. So this is, operator notation is kind of a weird hybrid between the two. I do like the straight Leibniz, but I didn't put it in that term. If you wanted to do straight Leibniz, it would be DUV. We let U and V move with X, then du dv over dx equals du dx times v plus u times dv over dx. I encourage you to keep the order in that direction, by the way. I encourage you to do it in this order. The derivative of the first times the second plus the first times the derivative of the second. The reason why is the quotient rule has that same order, but the quotient rule has a minus in it. So yes, it'd be technically correct if you flip these two with the plus, but the quotient rule has a minus in it and with the, over v squared, and it's easy to forget that. It's easy to mess up the order. And I'll show you a couple tricks on how to remember it. Because I honestly did not remember that off the top of my head until I started thinking calculus. Sorry, until I started teaching this. Every time I wanted to use the quotient rule, I had to sit there and think about it for a moment. Which one was which? And I'll show you the trick to do that. Right. Now I could tell you it's the derivative of the first times the second minus, but that's just because I'm teaching it. I wouldn't have that off the top of my head if I wasn't. All right, so how do we feel about the state for question 3 there, 1 to 5? By the way, on the test, your definitions, your statements, they were bright. They were perfect. They were gorgeous. Well, not everybody's was perfect, but for the most part, they were beautiful. The graders were like done with mine in 2 seconds. They were like, oh, and then they were reading the other statements and they were like, what? And you guys were just, it was beautiful. You made me so proud. We're still talking about number 3, 1 to 5. I got 3 responses. 3 people give me a 5 on that, huh? That's all I get. There we go. I got a 4. I'm okay with that, by the way. I'm okay with getting low scores. It just means I need to talk about it. All right. Is the notation confusing or is it the statement of the thing? Okay. I'll corner you guys later if I figure out how to export the statistics. All right, this beautiful graph. Remember, I'm going to do it in 3 steps. The first thing I'm going to do is figure out what the heck it's saying. The second thing I'm going to do and make notes. The second thing I'm going to do is draw it, instead of draw it. And the third thing I'm going to do is I'm going to check to make sure I did everything. Okay, so this first condition says that I'm going to have x go to infinity. F of x goes to -1. So that's going to be a point on my graph. -2, 0 is easy. F prime of -2 equals 1. That means slope of 1 at x equals -2. Now I'm going to stop. I'm going to put infinity here, -1 on this graph. There it is. I'm going to put -2, 0 on this graph. There it is. And now before I do anything else, I'm going to put slope equals 1. And I'm going to put a positive here. That's for me because I mix up left and right all the time. Okay? So the minute I think of the fact that it needs to go that way, I write it. Now, whether or not that's, I'm a little dyslexic or less lexistic, as I like to say. And, that really, those things throw me off all the time. So I just like to make myself a little note that make sure I don't mess it up. All right, I got a continuous everywhere condition. I'll just write that. Let's see. F prime of 1 does not exist. Well, it's continuous, but F prime of 1 doesn't exist. That means there's a kink there. And, dadgummit, stop. Go away. And what was the last one here? Is if x is greater than 1, then f prime of x is less than 0. All right, so what does that mean? That means the slope of the tangent lines. If I'm greater than 1, the slope of the tangent lines are going, I can't tell if I'm doing this the correct direction, that way. They're going down. The slopes are going, the slopes are negative. The slopes aren't going down. The slopes are negative. That means the function is going down. This is decreasing. So I'm going to make up myself a little note. From 1 to infinity, I need to be going down. One to 5, how do we feel about the interpreting of the conditions here? Okay, little rough. Okay, well, let's draw it. Now, I'm going to go left to right. And notice I've got no requirements over here, right? It's just kind of, this graph is just kind of in the air. Do what you want to it. Well, I need a slope of 1. The easiest way to get a slope of 1 is to draw a nice little line. You didn't have to draw a line. You could have had a little curve with a tangent line. In fact, you know what? That's what I'll do. I'll do a little tangent line. So something with a curve. So I could have done it like this. If you watch the 11 a.m. video, which is already up on YouTube, Scott's getting faster. I'm actually learning. I'm getting faster at Premiere. So I'm able to cut those videos a little bit faster, and that was a common request. So the 11 a.m. video is already up on YouTube. You can watch it there where I actually did one with a straight line. But here I'll do something a little different because it's my function. I get to decide what it looks like. I'm going to have it have a horizontal tangent line here. I'm going to have it go off this way just because I feel like it. I'll have it go off. You know what? I'm going to have it go off right here just because I feel like it. I'm going to have it come down, and then I'm going to have it come like this and have a nice little tangent line of 1 right there. Because you know what? It's my function and I feel like it. How do we feel about that, right? I can just do what I want to with it because it's mine. Let's see. Oops. Multiple choice. My function. 1, 2, 3, 4, 5. So it's my function. I can do what I want to do with it. Okay, as long as I meet the conditions, it's mine. So what I'm going to do is I'm just going to have a little tangent line with a slope of 1. It's not Scott's function. Well, it is. This one's Scott's function because it's mine. All right, and I just feel like it should come up here, kind of just hang out. And then I'm going to give him a little kink because remember, I need a kink right here. Okay. The slope of 1. So the slope of the tangent line has to be 1 because f prime of -2 equals 1. Not f of -2, f prime of -2. F prime tells me the slope of the tangent line. Now I can make it 1 if you look at at this morning's notes, right? I made it 1 there. That's 1. Nice slope, right? Slope of 1. That is a perfectly legitimate way to do it. This is just me feeling like it. I just felt like going a little nuts. And now I need it to come down here, and I need it to kind of always be decreasing. I can't just have a flat line go off to infinity. So from here on out, I just got to head down. That was just kind of stage 2. And now what I'm going to do is I'm just going to check. And I'll write a little kink here. I'll put a horizontal tangent line. Not a horizontal tangent line, an asymptote line right here. A little low. Yep, and there it is. So now I check. Is it true that as I go to negative, as f of x, let's see, as x goes to infinity, is it true that f of x goes to 1? Yes. I'm sorry, f of x goes to negative 1? Yes. Is it true that f of negative 2 equals 0? Yep. Is it true that the slope of the tangent line, is it true that the derivative here is 1? Yes. I even drew a nice little tangent line to help. Is it true that f prime, oh, and if you do this, do draw the tangent line. Because otherwise people are going to look at it and go, Is it true that f prime of 1 doesn't exist? Nope. The derivative from the left does not equal the derivative from the right. The slope from the left does not equal the slope from the right. Don't try to pull off the infinity thing, by the way, don't try to pull off the x cubed at 0 type infinity type thing on a test. It will, I mean, I'll give you credit for it after you argue it, but, you know, it's not a happy thing. Is it the true that I'm decreasing x is greater than 1, then f prime of x is less than 0? Yes. And is f continuous? Yes. All right, so altogether, how do we feel about this graph? So question 4, 1 to 5. All right, and if you're having trouble with them, come see me during office hours. No one from Calc came to see me today. I was hurt. Like 2 people from Discrete came too. 300 students. Oh, no one. 2 came to office hours today. It hurt my feelings. Okay. So don't hurt my feelings. Come to office hours.